On this video tutorial, we're going to show how to change some default parameters to change the visual layout of your map. A lot of these are up here in the settings menu, and the first few I'm going to point you to are the simulation parameters. So you can change a lot of these to change how this force directing is done. So for example, if you change link repulsion strength or no repulsion strength, you can see your map getting larger as things repel each other more. Another one you can do is this node collision buffer. So you can see a lot of the times the nodes will sort of be touching each other, sort of in the same space over here, and you can add a buffer to them. That's this node collision buffer parameter. So if you can see now, they're a little bit more spread out. This inertia parameter goes from 0 to 1, and that's sort of how responsive the graph is. So if that's large, you have a lot of inertia. So if you grab a node, it's kind of slow to get back. And if you have it to a low value, it's very responsive. So once you drag it, it goes right back to where it was. You can see things move a lot faster. The center strength, so each graph, each map is going to have a center. You can look at it by adding the center size. That is that node right there, that black dot. You can't click on it or drag or anything. It's more really for reference. It's added sort of as a north for when you're moving things around. And all of the graphs, all of the nodes in the graph will gravitate towards that point. So if you select them all and just drag them all over here to the side, they're all going to sort of go back to that center. You can change that strength. So if you take it up to a lot, 0.2, you can see them all just gathering around the center point. And the reason we have this parameter is if you set it to 0, if that wasn't present, you can sort of see your components drift off, and you can have a reaction or something drift off just really, really far. Right, I'm going to drag it all the way over here, right, and then you can sort of lose touch of where it is. So by adding just a little bit of the center strength, you can sort of see your nodes stick together. Prettify size, again, if you prettify a reaction, it's just sort of the size of that prettify. So if you make it larger, now you can see that reaction is more spread out. Right. Naming, you can name nodes based on different things annotated. So name them, label them by name. Right now they don't have reaction IDs, they have the actual names. Reversibility is another one. There are three different options. Reversibility none, that just shows the direction in which the reaction is annotated. Right? So if you let's just take this reaction for example, alanine and glyoxylate are products, and they go into pyruvate and glycine. They're substrates, and pyruvate and glycine are the products. And this is the direction that's annotated. That happens to have a reaction, but you don't know whether they're reversible or not. We have this parameter over here, lower bound, and this is the default value, and this is how reactions are annotated or as reversible or not. So Sam is going to look for this field in each of your nodes. So for example, if I look over here, this reaction, the fourth row from the top, we have a lower bound of -1,000. So that's actually a reversible reaction, right? And you see the lower underscore bound. And that's what Sam is going to look for to see if it's reversible or not. So if your model is annotated differently, just change that parameter right there. But if you say, for example, both ways, that's going to add arrows in both ways. So this reaction that is reversible, now we see arrows both ways. Whereas this one, which is not a reversible reaction, you see a lower bound of 0, we see that they remain the same. So this tells you which reactions are reversible, but it doesn't tell you the direction of annotation. So the third way are these diamond arrowheads. So in this way, reversible reactions are annotated by diamond arrowheads, and non-reversible reactions are annotated by normal ones. So this way you get both reversibility and direction of annotation. And the last little bit, node shape, you can change which ones are squares, which ones are circles, and so on. Some things you can do over here, you can hide reaction nodes. Right, so if you do this, you can see the reaction nodes are gone. You keep their name, but the nodes are hidden. You can move labels. So this will let you move the labels, offset them a little bit so they're not in the same spot always. And if you move the node, it sort of moves relative to where you place the labels, right? And once you remove here, you can't click on that anymore, right? So that text isn't clickable anymore. Now the interesting one, link string, that is going to color your links by how long they are. So that sort of allows you to see which links are very long or are sort of leaving the graph to be highly connected. Right? So we can remove that. Sizing, again, here we have a lot of default parameters. Arrow size, make them larger or smaller. Reference node size, so this is that can be a useful one. So let's say we have our whole graph, we want to choose everything, and we want to scale it, right, by making it larger or smaller. But if you have a really big graph and we want to scale to be really far apart, if we do this, it can be kind of hard to click on that little node. So just say reference node size, we're going to take that up to 20, right? And now we have a really big reference node and it's easy to click. So this is a matter of how much you want to zoom the node, the graph in or out. Once you let go, that node disappears, right? Again, these are pretty self-explanatory. Node size, make them bigger, smaller. Label size, bigger, smaller. You can play around with it to make them however you want. Another little bit is you can view size reference over here. So that is going to put node sizes and things over there. So once you map data, this is going to give you a scale for size of the node. So what each size really represents. And these are all for map data down here. Edit text size, so you can actually annotate some text. Here, add text and shape, there's another video tutorial for this. I refer you to that for more details, but here you can add something and say, oh, this is what I call this. Right? Once you do that, that's what this this parameter is for. Right? So that makes it bigger or smaller over there. Finally, you have down here you have some default values for reference node and map data, but here you have some some default color values. So as you go around, fixing nodes, if they were all the same color, you wouldn't be able to tell which ones are fixed, which ones are not. It would be kind of hard to tell. So you can color them differently, right? So let's say, for example, fixed nodes are going to be purple. Fixed reactions are going to be some other color. You can change that. You can change default edge color. If you don't like gray, you can just make it black, and so on. So these are a lot of the default values you can change to change appearance, to change how the force directing is done, and so on. One last thing I'll point out is if you want to change how the nodes are labeled, for example here hydrogen, we split them, and let's say this reaction takes 2 hydrogens, for example. We can annotate stoichiometry right on the node. So here we have them being labeled by name. So I select this node, say edit attributes, and now instead of name being age, we're going to say 2age. Right? Now that reflects that over there. So you can change also, you can not only change what they're labeled by, but you can change that field using here the edit attribute. So these are some of the ways that you can change your default visualization and how the map is laid out.